Welcome everyone. Welcome to MJ's Maths and Stats with volume 1.2 Get specific questions related to permutation and combination. How many numbers of up to 5 digits can be created using digit 1, 2, 3 and 5? We have only 4 digits. Each at least once, means at least once we need to use this digit such that they are multiple of 15. That means it should be divisible by 3 and it should be divisible by 5 too. Now we can't frame a 1-digit number, 2-digit number, 3-digit number because all the 4 digits need to be used at least once. So let us try framing 4-digit number first. And since we have got 4 digits and each digit need to be used at least once, so for 4-digit number we can only use 1, 2, 3, 5 once. Now 1 plus 2 plus 3 plus 5 is 11. That means sum of digit is not divisible by 3. It clearly means that we also cannot form 4-digit numbers. Now the option is only to frame 5-digit numbers such that these 5-digit numbers are divisible by 3 and 5. Now if it is divisible by 5, the last place has to have 5. In the end we should have 5. And now the sum of digit should be divisible by 3. Now what can be the combination we can have in these? We need to use 1, we need to use 2, we need to use 3. Now 1 plus 2 plus 3 is 6. We can use one more 3, isn't it? Then it will be 9. But 9 plus 5 is 14. That means 6 plus 5 is 11. We need to make 12. Yes, instead of 3, if we use 1, then the total would be 12 and that is divisible by 3. So how many numbers we can form with digits 1, 2, 3, 1 to be arranged in 4 places? It would be factorial 4 by factorial 2. 24 by 2 is 12. Can we have some other case? Instead of 1, if I need to put in another digit, it should be minimum digit, it should be 4, but we don't have 4. Or 7, we don't have 7. That means only 12 numbers can be formed under the given condition. Answer is 12. A train is going from A to B and makes 6 stops on the way. 4 persons enter the train after it has started from A with 4 different tickets. How many different set of tickets may they have had? So nobody is boarding the train at A. They can board at station 1, 2, 3, 4, 5 or 6. Nobody will board at the end terminal station. Now, if anyone boards at station 1, he can hold how many different types of tickets? 1, 2, 3, 4, 5, 6. If he is boarding at station number 2, how many different types of tickets he can have? 1, 2, 3, 4, 5. Plus 4 if he is boarding at station number 3. Plus 3 if boarding at 4. Plus 2 if boarding at station number 5. And plus 1 if boarding at station number 6. 1 plus 2 plus 3 plus 6, 15 and 6, 21. So in 21 different tickets can be there for 4 people. Now we need to choose only 4 out of this 21 because 4 persons have entered during the journey. So out of 21 different positional tickets, in how many ways 4 people can be chosen is 21 C4 ways. How many 5 digits distinct number, repetition not allowed, can be formed with the digits 0, 1, 2, 3, 4, 7, 8. We have 7 digits and we need a 5-digit number with all distinct digits such that they are divisible by 9. A number is said to be divisible by 9 when sum of digits is divisible by 9. So our task is just to identify 5 digits where the total would be divisible by 9. Now what is the total? 15, 19, 20, 25. Here total is 25. So the first number which is divisible by 9 and in 25 is 18. If I deduct 7, I'll get 18. So if I leave 7, but I need to leave 2 digits. So let me leave 4 and 3. So with 0, 1, 2, 7, 8, I can frame 5-digit numbers and this would be divisible by 9. Now with I need to leave out 2 digits again. Now we also can have 1, 2, 3, 4, that is 7 plus 2, 9, and 1 is 10 and 8. Okay, I release 0 and 7 is transformed to 3, 4, and then we again have 18. So we will have two combination, case 1 and case 2, where total is 18. Now how many 5-digit numbers can be formed? If 0 is also there, it should be 5p5 minus 4p4. 120 minus 24 is 96, and with these 5 different digits, distinct 5-digit number form would be 5p5, that is 120. So total 5-digit number that we can form is 96 plus 120, that is 216. Find the number of ways in which 4 squares can be chosen at random on a chessboard such that they lie on a diagonal. So let's see a 8 into 8 chessboard. So this is an 8 into 8 chessboard. Let us name it A, B, C, D. We need to choose 4 squares which should be on diagonal. Now let us consider the first diagonal BD. How many squares are there on this diagonal BD? 1, 2, 3, 4, 5, 6, 7, 8. So out of these 8 diagonals, I need to choose 4 at a time. That can be chosen in 8C4 ways. Now if we see column 7 and this diagonal is 1, 2, 3, 4, 5, 6, 7. So out of this 7, in how many ways we can choose 4? Is 7C4. But if we see row 2 here, here also we have this same diagonal 1, 2, 3, 4, 5, 6, 7 with 7 squares. Then this diagonal and this diagonal is symmetric. That means in how many ways we can choose now on these two diagonal? 7C4 into 2. Now we look at C6. We have 1, 2, 3, 4, 5, 6. So it would be 6C4 into 2. Now we look here. 1, 2, 3, 4, 5. Should be 5C4 into 2. 1, 2, 3, 4. It should be 4C4 into 2. But we go to this particular diagonal. There we have only 3 squares. So no square can be chosen on this diagonal. Nothing on this diagonal and nothing on this diagonal. So we have 4, 5, 6, 7 and then 8. 4, 5, 6, 7 are symmetrical. We have got 2 pairs of such diagonals, and for 8C4, for the diagonal with 8 square, we have got only one diagonal BD. So let's calculate this now. 8C4 is 70. Now this is with respect to diagonal BD. If we look at diagonal AC, same format we can get if we are looking at diagonal AC and the corresponding diagonal on the two sides. That means in how many ways this job can be done is 182 into 2, that is 364. With unlimited supply of 8 types of flowers, a customer asks for a 5-flower arrangement such that the arrangement should start and end with the same type of flower. Then in how many ways the arrangement can be made? We have 8 types of flowers, that means 8 different types of flowers are there. We can put any one flower on the first place. In how many ways? 8 ways. Now they have just asked about the different arrangements such that first flower and the last flower is same. Second flower may be same as the first one or may be different. So again 8 flowers can be placed on the second place. 8 flowers can be placed on the third place. 8 flowers can be placed on the fourth place. But on the last place we can have only one flower placed, which should be same as the flower placed on the first place. So the job can be done individually in 8, 8, 8, 8 one ways, and the connector is our English and mathematical multiplication. In how many ways arrangement can be done? Is 8 to the power 4 into 1, that is 8 to the power 4 ways. A 5-digit number is formed using digit 1, 3, 5, 7, 9. Repetition is not allowed. What is the sum of all such possible numbers? To find the sum of all such possible numbers, we just follow 2 simple steps. First step is, let's find sum of digits and multiply this by n minus 1. Sum of digit is 10, 20, 25 into factorial 5 minus 1. That is 25 into 24 is 600. Now this is a 5-digit number. In step 2, I'll write 600 after 1 shift towards the left. How many times? 5 times. And then add up these digits. 0, 0, 6, 6, 6, 6, 6. How many distinct, means repetition not allowed, 5-digit numbers can be formed with the digits 1, 2, 3, 4, 5 when the unit digit, this is unit digit, is greater than the 10th place digit. Fine. We can develop cases in this. I cannot have 1 in the unit digit, isn't it? Because unit digit need to be greater than the 10th place. I can have 2 in the unit digit. Then I should have 1 in the 10th place. Now the remaining 3 would be arranging themselves in 3p3 into 1 ways. 3p3 is 6. 6 into 1 is 6. Now if I have 3 in the unit place, I can have 1 or 2 in the 10th place, and these 3 places are free again. So this would be 3p3 into 2p2 into 1. So that would be 6 into 2, 12. Again, if I take 4 on the unit place, I can have 1, 2 or 3 in the 10th place. So this should be 3p3 into 3p1 into 1. 6 into 3, 18. Similarly, if I take 5 in the unit place, in the 10th place I can have 1, 2, 3 or 4. So how many numbers can be formed? 3p3 into 4p1 into 1. 6 into 4 is 24. So the total is 10, 20, 30, 40, 50, 60. 1 red flag, 3 white flags and 2 blue flags are to be arranged in a line. That means we have 6 flags are to be arranged in a line such that no 2 adjacent flags are of same color. Done. And the flags at the 2 ends are of the same color. In how many different ways can the flags be arranged? So let's start. flags at the two ends are of same color. That means at the two end we cannot have red color flag because we have got only two red color flags. We can have both whites or we can have both blacks. Okay, let's start with both blacks maybe. Black at the beginning and black at the end. So we are left with 1, 2, 3, 4 position. Now in these 4 position I need to arrange 3 white and 1 red. Now look carefully, we have 3 white and 1 red. If I put white, 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 red, I'm missing out with this particular thing which says no two adjacent flags are of same color. If I put W, R, W, W or R or W, W, R, W, anyway if I try to arrange, it's not possible for me to have no two same color flags adjacent to each other. That means what? Beginning and end cannot be with blue color flags. Not possible. That means we should have white color flags at the two end. Now we are left with 1 red, 1 white and 2 black. Let's see in how many ways we can arrange these in these 4 places. If I start with red, since I have 2 blue, red, blue, white, blue, that can be there. Then B, R, W, B is possible. B, W, R, B is possible. And I don't think any more cases are possible. I can't start with W here. So that makes us easy for us to find the cases. At these 2 positions, W cannot be there. It can be either blue or red. 2 blues are positioned, R, W, W, R, done. And when R and B is positioned, it should be B, W. Or if I try to make W, B, then 2 B's would be together. So we can have only 3 cases. How many 7-digit odd numbers are there whose first 3 digits are 635 or 674? Bingo. Let's take this as case 1 and take this as case 2. In case 1, already 3 digits are occupied by 635 and now we are left with 4 digits. One more condition is there. 9 appears once. Digit 9 should appear, and that too only once. It cannot repeat. Otherwise all other digits may repeat. Now how logically we need to go slowly, step by step. These all are odd numbers. That means last digit can be either 1, 3, 5, 7 or 9. Now look, if I take last digit as 9, then in these 3 digits I cannot have 9, but I can have 0 to 8 any digits. That means this digit can be occupied by remaining 9 digits. This can be occupied by remaining 9 digits. And again, this can be occupied by remaining 9 digits. Fine. That means how many numbers we can form where it is ending with 9? It is 9 cube, that is 729. Now, at the last position, if we have 1, 3, 5 or 7, 1, 3, 5, 7 appearing at the end, 9 can only appear once. That means what? Out of these 3 places, 9 will be occupying at only 1 places because it need to appear once. कौन से place पे 9 आएगा? In which place you will see 9? In any one of the place selected in 3C1 ways. And at that position, you will place a 9. Fine. Now, you are left with 2 positions. And on these 2 positions, you can have any digits but not 9. any 9 digit but not 9 on these two positions. So if the number ends with 1357, how many numbers we can form? Ending with any of these 4 digits. For this 3 digits, we have 3C1 into 1 into 9 into 9, and from here we can have 1 digit at this place, 4P1. So total number of numbers would be 3 into 81 into 4. 12 into 81 is, that is 972. So for case 1, total number of 7 digits odd number that can be formed are 729 plus 972. That is 1017. 1701. Similarly, 1701 numbers can be formed in case 2 also, because here also we have 674, there is no 9, so it should be treated as same as case 1. Total number of numbers required is 1701 into 2, 3402. How many 3-digit positive numbers XYZ with digits XYZ exist such that X is less than Y, okay, X is less than Y, and Z is also less than Y. Z is also less than Y, where X is not equals to 0. Fine. X cannot be equals to 0. And X is less than Y, Z is also less than Y. That means we can start with digit 2. Okay, so minimum value that Y can take is 2. X will take 1. Now in place of Z, Z is less than Y, we can have 0 or 1. That means how many numbers can be formed? 2 numbers can be formed. 1 to 0 or 1 to 1. Now if I take Y equals to 3, in place of X I can have 1 or 2, and in place of Z I can have 0, 1, 2. Then how many numbers would be formed? 2 into 3, that is 6. Now if I take 4, in place of X I can have 1, 2, 3. In place of Z we can have 0, 1, 2, 3. That means 3 into 4, that is 12 numbers can be formed. Let me take one more. If I take Y equals to 5, I can have 1, 2, 3, 4 in place of X, and 0, 1, 2, 3, 4 in place of Y. So it should be 4 into 5, that is 20. Now the last digit which we can place at Y is 9. So we can have 1 to 8 in place of X, and we can have 0 to 8 in place of Z. So it should be 8 into 9, that is 72. If we look carefully, what we have got is triangular numbers, and we need to add up these. It is 240. Thank you everyone for participating. This is Mohit Jain signing off from MJ's Maths and Stats. These were few questions related to permutation and combination. Stay connected with us for questions and comments. You have this Telegram number and email ID on your screen. Feel free to text us. Feel free to email us. I'll see you soon. Thank you.